Hello, I'm JW. This time we have another couple of consumer units to look at, and these are an older type. These are from the sort of 1970s and 80s, but nevertheless there's still plenty of these things out there, and they're certainly something that may well come across in various properties. And there's not particularly any reason to upgrade these, other than the lack of having an RCD in there, but if you just want to keep it as is, then generally there's no problem in doing that. Now, first of all, we've got this unit here, which is made by Square D, a company which has been taken over and merged into somebody else, but this particular one is from the mid-1980s, and it's quite typical of the sort of thing installed around that time. This is a plastic one, so allegedly would not comply anymore, but that's a matter for another video. And inside here we've got a RCCB, or basically RCD, which covers the whole lot. And for that reason these things are not particularly permitted anymore, because you're supposed to have more than one RCD, or proper options have individual RCBOs, but this one has just a single main switch here which incorporates the RCD function, and that controls all of the circuit breakers installed. Now this one has one missing. There should be a blanking plate in there just to fill up that hole, as if you put your fingers in there then you can touch live parts inside. Now, so this is mid-80s, this particular one, and the breakers in here are fairly typical arrangement. We've got cooker here, ground floor sockets, first floor sockets, ground floor lighting, which I think in this case actually did all the lighting, because obviously there's only ground floor, so unless upstairs didn't have any, probably all on the same one. And then this one at the end has been added obviously a bit later on for a shower. See, there's actually a slightly different design on the front there, and plus someone's scribbled in with a pencil instead of using the printed labels that will be supplied with it. And number 6 is not used, so there should be a blanking cover over that. Now, just to remove the lid on this. So inside here we've got the devices in the middle and the main switch here. And on this particular design, the incoming cabling and things actually attaches at the bottom. So these are the two terminals for the incoming neutral here and the line here, as marked on the label. And this is the switch here, which essentially is on in that position and off in that. And has this test button here, which you're supposed to press at intervals, as it says on this somewhat damaged label, just to make sure that the thing actually turns off. Now, the problem with this design is that because you've got an RCD on everything, any fault anywhere can cause this thing to trip, and the problem then it's not immediately obvious where the fault is. So it could be that the cooker element has busted, or say an outside light has got water in it or something. And the other major problem here is if you don't know where the fault is, you can't really do much about it. So the poor householder could be stuck there, this thing switched off, and if fault still exists you won't actually be able to switch it on again. And it's going to stay like that with no power to the whole building until the fault is found and fixed. Now, of course, you could go around to unplugging all your appliances and turning off the cooker at the isolator switch and so on, but in any case it's still going to be pretty inconvenient. And of course some faults may not be immediately obvious. Say if it was the outside light which has got some water in it, switching it off if it's on a single pole switch may not actually remove the problem. So this sort of thing is not permitted to be fitted any longer, and in reality probably shouldn't have been fitted at the time either, but nevertheless it was a fairly common deal. Now, these circuit breakers are the plug-in variety, and they basically just snap onto this plastic bar here at the bottom, and then the live contact is actually on this metal bus bar here at the back. And then at the top here you've got your terminal strips for the neutral over this side, again numbered 1 to 6 for each of the connections there. And again you've got your earth bar here, again numbered 1 to 6, and then the additional connections there for any bonding, and of course the main earth wire that comes in. Now, the breakers themselves will actually just pull out, so snaps off the bottom and then pulls away from the top. Now here's a close look at this one, and you see you've got the sprung prongs here actually as part of the circuit breaker itself, and this clip at the bottom is just simply to attach to the bottom piece within the board here. It just snaps over that plastic rail bit at the bottom. And then this is your live bus bar, which is why it's important to have that blanking plate put in. Otherwise you could reach in and touch this, and of course that's a live piece of metal there. And they simply just say snap over the bar there, and it's got the little indicator window there to show that it's either off or on in that case. Now, I've just removed all of the parts from this, and you can see the actual thing itself is rather simple design. You've just got this plastic strip along the bottom where the things just clip over those pieces of moulded plastic there. This is the bus bar here, which is your line connection, So it just goes along to each of the individual circuit breakers. And then the circuit wiring in these actually attaches in the bottom there. So it just sits in there, and then your cables go in the bottom of each device with the screw to clamp that in position. And so on the back you've got those just tabs there to snap over here and of course here. And the neutral in this one, again this is your main switch here, so that will just come in at the bottom on the screw terminals there. And the neutral one is here, just simply a short piece goes straight up to the bar here, and then all your circuit neutrals connect into this one. And the earth is totally separate, so your main earth would go into this end. Bonding here for your gas and water and maybe other things into these two. And then you've got your numbered terminals there for the actual wires for each circuit. Actually missing a screw there as well. Now the main switch on this one is an RCD, and it's one of these 30 milliamp rated items. And that's normally the sort of thing you would fit these days, but say unfortunately this only has one for the entire installation, which isn't really permitted. And see on the back here it's the same arrangement as the circuit breakers. So again you've got that clip at the bottom, or two in this case, and then just the metal sort of prongs on the back there for connecting the line and neutral. And again, that just snaps into the holes here. And then just connects obviously to the bar here and the bar at the top. Now these circuit breakers are made to an older standard, which was BS3871. That's no longer valid, but nevertheless there's nothing wrong with continuing to use circuit breakers made to that standard. And the other type here, which is a slightly newer one, fairly similar, it's just got the rating printed on the device rather than, as in this case, stamped onto the end of the handle. That's always a bit difficult to read. And you'll see that this one, which is a later one, has more plastic covering over the live parts here, whereas that one's just got a effectively fully exposed metal connector there. But essentially they're both the same design. This just has to be a slightly later one that someone's obviously added in when they were fitting an electric shower. I just reassembled that there. And note on this one we've actually got some type 1 and type 2 there. Let's have a closer look there. And the type 1 and 2 essentially is the tripping characteristics, so there's actually a type 3 and a 4 as well. And although not identical, it's similar to the type B, C and D you can get on the newer series ones. And you also notice this one has an M6 on here. That's basically the maximum fault current, which in this case is 6,000 amps. And this one's actually rated M9, which is 9,000 amps, so slightly different ratings there, but mainly due to it being probably a later design. And although this has got a spare slot here, it's not the sort of thing you really want to be adding an extra circuit to, because the problem is that this technically doesn't comply anyway, simply with that you've got one RCD covering the entire installation. And of course if you're going to add an extra circuit in there, you're just making that situation even worse. So although you could obviously continue using this, adding an extra circuit here and extending it via that is not really an option. So you're going to have a hard time explaining that that's actually compliant with the new regulations. But nevertheless, nothing wrong with keeping this in service and in operation. And if you just want to say add a socket or something or move something around, then again perfectly fine, as you've got the RCD protection there. Now the second item we've got here, and again a similar sort of arrangement. This particular one is made by Crabtree, and as you see this one is all metal. And see in the top there, it's got where the holes where the wiring used to go in. And this is a substantial and fairly heavy item. Certainly a much better quality than the plastic thing we saw before. And again, this is a fairly common type, or at least it was when these were fitted. This is probably from the sort of 1970s or early 80s. And this one just has a main switch, and in this case has 6 individual circuit breakers. And again, if you've got one of these, there's nothing inherently wrong with it. But the main problem here is that there's no RCD protection on any of the circuits. So of course, if it comes to sort of adding sockets or changing anything, then pretty much you're stuck, because most alterations and additions now will require RCD protection, and so this simply does not have that. So let's have a look inside. So I'm just going to open up the screws on this particular one. Now these are actually C50 circuit breakers, and despite the name they're not rated at 50 amps and they're not type C either. It's just the fact that C50 is the model number given to these things. And C50s were a very common type of circuit breaker, and installed in literally probably millions of places. Now, front cover for this is just solid steel, just a cut out in the front there, and then inside, you can see we've got the various components there. So this again is similar to that square D one, where you've got your incoming wires here coming in from the bottom of the switch. Circuit wiring would attach to the bottom of the circuit breakers here, and then we've got the neutral bar up here on the top left, and the earth bar is the one down here attached through to the metal case itself. And on this particular one you'll see that the earth connection is actually on the outside, so you've got that sort of threaded part there, and then it just goes straight through to the 6 terminals inside. Now, say this particular one has a main switch, which say does have no RCD protection, and it simply is just a switch, so it's on and off. It doesn't have any overload or anything in it either. The only actual protection is via the circuit breakers inside. And we've got the live bus bar here along the top, and you see that's completely exposed, so when this main switch was in the on position, that's all live metalwork along the top, so certainly you wouldn't want to be touching that or even opening this up with the switch in the on position. And notice when it's in the off position, which is down, it has this little cover thing which just comes down to cover over those terminals, other than leaving a hole for the actual screws themselves. So it's a reasonably good feature. And you see under there the actual metal is somewhat recessed into the moulding of the switch there. So live all along the top simply goes through each of the circuit breakers and then comes out, so your circuits would connect here at the bottom. Neutrals all connect up here, and again there's 6 of those to correspond with the 6 circuit positions. And it's got this sort of fibrous shield here, which is mainly just to protect from the actual bar at the top, because bearing in mind that if you're going to have wires things coming in the top here, you don't want them to be coming into contact with that. And so it's just sort of a bendy piece of plastic along the top there. Now to remove these is actually really simple, they're just screwed in at the top there. So if we just unscrew this, just as much as undoing the screw at the top there, and then this whole thing just pulls out and unhooks from the bottom. Now the top there, you see, is just a tab with a hole in it, and the bottom where the wires go is just sort of a U-shaped piece which clamps over the tab on the bottom, so you just put the wires onto the bottom of that. And to actually attach to the bar, you just got basically 2 little hooks here. These got a bit of corrosion on, and they just hook into the 2 cutouts here on the bottom of this circuit breaker, and then it's simply a question of it screwing in the top. You notice there's no sort of rail or anything to it to actually attach to. It's just held in by that single screw at the top and the 2 little tabs at the bottom. Now we'll just take out the one next to it as well. So again, it's just undoing the screw at the top there. It just lifts forward and literally just lifts out. Now these screws are supposed to stay inside of the actual threaded piece there, so they generally remain captive like that. This particular one appears to have come out, but never mind. Hardly the end of the universe. But these are made from basically brown Bakelite, and you see on the side it's that BS3871 again there, and again raised up to 415 volts, as you could fit these in 3-phase boards as well. And they have a decent sort of snap action on the front there, and the rating for these is just printed on the end of the handle, so 5 amps in this case, with your on and off writing on there. And fairly substantial things, a solid brown Bakelite, certainly not going to be falling apart in a hurry, and it's made in England on the side there. And again we've got the Type C50, but of course this is actually a 5 amp version. That C50 does not refer to the operating current or the actual type of tripping either. So I've just removed all of the breakers from there, and you can see it's basically just the switch here. As an assembly, you could actually get RCDs to fit here instead. That would be a very similar line to the previous one, so that would cover all of the circuits. And a live bar at the top there, and of course you just hook in and screw in onto that bar like that. So quite a sensible design, and certainly nothing wrong with continuing using it. So the only problem again is that in fact you've got no RCD on this, and there's not any practical way of adding it other than changing the main switch to an RCD, but again that's not actually permitted either. So if you've got one of these in your installation and you want to add extra circuits or extra sockets or whatever else, then unfortunately it does mean usually changing the whole unit, or at the very least adding a RCD unit separately elsewhere. So for example, if you're just changing the lights in your bathroom or something, you could add a small RCD outside just for that purpose. And say these are 3871, same as the previous ones. and these are M3 rated, which is their main downfall. That refers to the fault current they can deal with, in this case 3000 amps, which is fairly low. You could also get some which dealt with up to 4.5 or 4500 amps. They generally had the yellow writing on the handle instead of white. But yeah, nothing wrong with them. You can still get these in fairly easily from various used and possibly new suppliers. But unfortunately it's the lack of RCD which is really the end of the line for these units. So look there at two older type consumer units, although plenty of those still installed and in service. And yeah, nothing inherently wrong with keeping those there. And of course the main trouble occurs when you want to add things to it or extend the installation, because on the Crabtree one here, the metal, you don't have any RCD protection at all, and there's not any way of really adding into those units. And on the other one, although you've got an RCD, it's only covering the entire installation, and of course that's the sort of thing which isn't really permitted on the current regulations, and in actual fact was probably never permitted. So again, you can keep these things in service, but when it comes to adding extra circuits or whatever, then it's pretty likely you're going to have to change them, or at least provide some RCD protection outside of the consumer unit. But nevertheless, they're quite reasonably made. Certainly the metal Crabtree one is far more substantial than most of the tat that's generally sold today. But until next time, thanks for watching.